In systems of equations, we generally have two unknown quantities that we have to solve for. And if we have two unknown quantities, we need to set up two relationships or two equations. So in this problem here, the first part he asks us to set up a problem, set up a system for this problem. So we have two planes cruising, they have a cruising speed of 570 kilometers an hour without wind. The first plane flies for 12 hours against the wind, and the second plane flies for 10 hours in the opposite direction with the wind. The second plane flies 370 kilometers less than the first plane. So what is we're trying to find two equations to find the speed and the distance traveled by the plane. So the distance traveled by the first plane, the wind speed and the distance traveled by the first plane. So we need to set up two relationships here. Okay, the first relationship is going to be the first plane. It's going to be the first plane, and they're going to be traveling at 570 kilometers an hour against the wind. So we're going to find the velocity, which is 570. And since they're going against the wind, we're going to go minus W. And they're going to travel for 12 hours. And that's going to equal the distance that they travel. So in this case, we've already set that up as D. Okay, so that's the first plane. We need to set up an equation for the second plane. Now the second plane is traveling with the wind, so we need a velocity. So 570 kilometers an hour. Now they're going with the wind, so we're going to go plus W. They're traveling for 10 hours, and they're going to travel a distance of D, but they're not going to go quite as far because the second plane flies 350 kilometers less. So we're going to minus 370 kilometers less. So we're going to do D minus 370. So we have in both cases here, we have velocity times, so velocity times the time equals the distance. Okay, so that's the velocity of the first plane, time for the first plane, distance for the first plane. It has to all coincide. Velocity for a second plane, since they're going with the wind, they travel for shorter distance. The second plane travels for 10 hours only. And since their second plane is 370 kilometers less, we have to account for that in the equation, 370 kilometers less. Okay, so we need to solve this system. So I'm going to, first of all, multiply through with that 12. So equation 1 looks like this. It's going to be 12 times 570 is going to give us 6840 kilometers minus 12 times W is equal to D. I'm going to do the same for equation 2, multiply that through, we get 5,700 kilometers plus 10 hours times the wind speed is equal to the distance minus 370. Now since the coefficients of D match, we have the coefficients of D matching here, we are able to eliminate the variable D by subtraction here. So I'm going to subtract these equations. I combine them by subtraction. So negative 12W minus 10W is negative 22W. Be careful of your positives and negatives. We're going to subtract 370. So we're going to subtract negative 370. So this is a subtraction here. So we're going to end up with positive 370 kilometers. Okay, so we're going to solve for W. We're going to subtract 370 from both sides. We get 770 kilometers. I'm going to add 22W to both sides. I get 22W. And then solving for the wind speed is equal to 770 over 770 over 22. That works out to be, there's a common factor of 11, so I'm going to end up with 70 over 2 when I divide out the common factor of 11, and I get 35 kilometers per hour for the wind speed. Okay, so there's our wind speed. We solve for our wind speed. We need to solve for the d, so we're just going to plug it back into equation 1. So I get 6,840 minus 12 times our wind speed, which is 35 kilometers per hour. And that's equal to our d that we're calculating. Okay, so we have, it's going to be, let's see here, 35 times 12. So 35 times 12 is equal to 420. Okay, so 10 times 35 is 350. 2 times 35 is 70. 350 plus 70 gives me the 420 here. Subtracting these two, I get 6420, and that represents the distance traveled by the first plane.